Hi everyone. Today I'm going to be demoing the Identify snap, which deals with decentralized identity, verifiable credentials. You can do all sorts of things here using the snap, such as resolving the DID, creating a sample verifiable credential. Obviously this is an example website, but you could build your own website that interacts with the Identify snap to offer similar features that you see here on this page. So here I already have a local instance of the snap running, so I will just go ahead and connect it for the very first time. You see here that we get some dialog boxes from MetaMask. We just go through with it, and here it says that Identify is ready to use, and here it's basically talks about the Identify snap, how it works, so on and so forth. Alright, first I'm just going to be demoing the hello world message. It doesn't, this API does not do anything by itself. It's just a very simple use case of an API for the snap, which basically triggers a MetaMask dialog box that says this particular message. You can see here that currently my network is hedera testnet, but it doesn't matter. You can connect to Ethereum mainnet, Linea, hedera mainnet, whatever it is. If you don't connect to, let's say you're connected to Ethereum mainnet, and we're gonna see this in a little bit, and if you were to use DID hedera method, then it's going to connect to the hedera mainnet to get the hedera ID. That's one thing to be aware of. Now, if you're already on something like hedera testnet, then obviously it will use the testnet, hedera testnet, to deal with DID hedera. But if you are in any other network, then it will assume that you're dealing with the hedera mainnet. All right. So there are 3 different DID methods that the Identify snap currently supports. One of them is DID PKH, which we had already put out on the first version, and now with this new version there are 2 additional DID methods that are supported: DID key and DID hedera. So initially, by default, it does select DID PKH, so we're just gonna go with that for now, and later we're gonna switch to other DID methods to look at various examples. All right, let's go ahead and remember that I am currently connected to hedera testnet, so if I were to deal with DID hedera, I will be interacting with hedera testnet. But anyways, for now, let's go ahead and just deal with DID PKH. So when I click on resolve DID, it is going to be resolving the DID according to the DID PKH specification. And in the background, we are using Veramo to handle everything, so everything is abstracted away. In the future, it's very easy to add in additional DID methods support, because we use Veramo and the modular nature of how Veramo works under the hood. All right, now I can get, this basically retrieves the account information. Currently it says MetaMask address, snap public key, and the DID, which is DID PKH, blah blah blah. This is the format of DID PKH method, but you might be wondering, there's 2 different addresses here: the MetaMask address and the snap address. So MetaMask, with snaps, what it does is it does not let any of the snaps get access to the private key of the your MetaMask wallet. So then what Identify does is it basically creates its own snap wallet, which still lives within MetaMask, and then that's why it has a separate address. There's a snap address, and the snap basically deals with this address for every single feature that we see here. And as far as MetaMask address, this is just to let everyone know that this particular snap account was generated while this MetaMask address, using the MetaMask addresses account. So what that means is, if you were to log into a different device, as long as you are using the same mnemonics to sign into your MetaMask wallet, and you're on this particular address, you will be able to get back to the Snap address. So it's very interesting how it works under the hood. But even if there is Snap, even if Snap creates its own wallet, as long as you're connected to that MetaMask wallet in the future in another device, another browser, it automatically generates the exact same wallet, because the private key for the Snap address is based off of the private key. Sorry, not the private key, but the way that the MetaMask address and private key is generated under the hood. So for something like Hedera, the coin type is 3030. So using with the appropriate algorithm, it will generate a specific Snap address. If we were to this is obviously made for Hedera, but we could easily make it so that in order to generate the Snap address, we could have used some other coin type, for instance, 60 or 30 or whatever it is, and it would give an entirely new Snap address. Anyways, that's just how it works under the hood. Feel free to check out the documentation, but let's go ahead and move on. So currently I do not have any verifiable credentials. So if I were to check this API, it's going to say that I have 0, which is okay. All right, let's go ahead and switch to DID key. And then now let's go ahead and do resolve DID. Now you can see here that it's a little bit different here. Oh, sorry. It's still using PKH because we have not changed the DID method yet. Okay, current DID method DID PKH, new DID method DID key. Let's go ahead and approve that. And then let's go ahead and resolve it. Now you can see here we are actually getting the DID key. And then the verification method, it has the JWT format and a bunch of other interesting information. This is the only thing that's going to be different there when you resolve the DID. As far as creating a verifiable credential, verifying it, removing it, all of those are abstracted away. So no matter what DID method you use, it's gonna look the same. So we're gonna take a look here. So let me just go ahead and create. Let me switch back to PKH. I'm gonna create a verifiable credential. Actually, let me just do this. I will do PKH Kiran. Actually, let me just do this. PKH, so it's easier to know. Okay, PKH. This is our verifiable credential. So we have this credential subject, profile name, nickname is PKH. It uses PKH. This is our credential, and automatically it will fill in the credential that we just retrieved. So if you wanted to verify it, you could easily verify it, which is correct, because it basically checks the public key from the verifiable credential, make sure that you are the legitimate owner, the VC verifiable credential is legitimate and it was signed by the appropriate address. So that's what it does. Now if we were to retrieve all the VCs, now we can see here that there is one credential, and it will list the details of the credential here. And when you do approve it here, it doesn't do anything, but in the background it's a way to basically retrieve the verifiable credential associated with this account from a third party. So you could build your own website that has some kind of login mechanism that retrieves a verifiable credential, and then check whether it is your verifiable credential that was issued to the user, and if so, then you log them in. There's a lot of use cases around that. All right, so let me go ahead and switch to DID key. It's the same here. So now if I were to check resolve DID, you'll see that we are on DID key. Let's go ahead and try to retrieve the VCs. And it is smart enough to know that because we have selected a different DID method, it's gonna know that, okay, we are on DID key, which means I don't have any verifiable credential created yet. So what I can do is let me do key here. What I can do is generate a VC. Okay, and then approve. And then now we have the verifiable credential that is using DID key. It has JWT proof 2020, and so on and so forth. Now, if we were to retrieve the VCs, it will show the VC, which is in fact correct. All right. Let me now move over to DID hedera. So that's what we're here for. DID hedera. So I'm going to switch from DID key to DID hedera. One thing to note is that DID hedera, it's actually based off of the Hedera official Hedera SDK. It uses the Hedera consensus service to create a topic for each DID, and then anytime there is any action like updating it, or in the first case generating the DID, and all of those kind of transactions are recorded as a message to the topics, and we're going to see that in a little bit here. So I am currently on DID hedera. I'm going to click on resolve DID, but this is going to fail. We will see why. You see here that this is our snap address. You can see here, we can actually go back here. We'll see. Oh, well, this is the snap address. It's saying that it could not get the account information from Hedera mirror node on testnet. Please note that if this account has been activated yet. So I'm going to go ahead. This is a requirement, by the way, to use DID hedera, because you are interacting with the Hedera ledger, and if your account is not activated, you're not able to interact with Hedera consensus service. So what we're going to do is, because it's a testnet, I can basically go here. I'm going to receive 100 testnet hbar. Okay, done. Now, if I were to go ahead and click on get account info, we shall see. Takes a while for it to set up. So here, MetaMask address is the same, snap address that we got, snap public key, and now we have the DID hedera testnet, blah blah blah, and then you see here this is what gets prepended. Sorry, added to the DID. This is basically the topic ID for the hedera DID. And then method is DID hedera, and our account is activated. So this is why we have the hedera account ID 5323.023. So now if I were to actually go here, you can see here it's already here. So now we can see, okay, first 100 hbar were transferred, which we use the hedera portal faucet, and then later it was the crypto update account. So this transaction was transacted, and then we created the topic, which is 5323.024, which is 5323.024. That's the topic ID for this particular DID. And then after that, we submitted the message, which in this case, the message is basically to create the DID on Ledger. And you can check out the information directly on Hashcan this way. All right, now everything should be good. So if I were to resolve DID, I should be able to get the actual DID resolution result here. Okay, this is our DID resolution result for DID hedera testnet. You can see here everything matches up, looks good. All right, now let's go ahead and try to retrieve the VCs. Well, there are no VCs, that's why it's going to say 0. All right, let's go ahead and create a new verifiable credential using our DID hedera method, and it quickly creates it. Note here that because this DID hedera method is special in that it is very specific to Hedera, we actually add a new field called Hedera account ID to the issuer automatically. This is basically the account ID of Hedera. So this way, you're able to quickly tell, okay, this is the account ID that this DID belongs to. Nickname Hedera, we chose that. Again, here, same thing. Hedera account ID is added, and the rest is the same. All right, so now let's go ahead and, so we played around with DID PKH, DID key, DID hedera. Now let's play around with some other functionalities here. So we know that verifiable credential works. You can put in any verifiable credential JSON output here, and it will automatically check and verify whether it is correct or not. All right, now let's go ahead and generate a verifiable presentation from our verifiable credential. So what this does is it takes in the verifiable credential and it generates a verifiable presentation out of it. So here you can see on the dialog box, this is our VC, and then we click approve, and this is our verifiable presentation format. So this is going to be especially useful for those use cases like I mentioned earlier, where you want to quickly verify the credential, and you want to see whether it is a legitimate credential, and if the verifiable presentation is also able to be generated using the user's MetaMask account, Snap account, then you know that the verifiable credential does belong to that user. So that's how we can get that. And then we can also verify the verifiable presentation. Here on this page, I have set it so that it automatically, whenever you generate a VP, it automatically puts it here, so we can basically verify the verifiable presentation here. All right, so it's gonna take a while because every time it has to make sure to go to the hedera ledger and make sure that the hedera account ID is legitimate. All right, so that's verifiable presentation. You can also delete a particular VC. So let me just create another one. So I have two verifiable credential. You see here, two. Okay, that's good. Now I want to remove one of the credential. Okay, I just have one of them here. So let me just go ahead and delete. You see here that it says you're trying to delete this particular credential. I'll just go ahead and approve it. Deleted. Done. Now if I were to retrieve the verifiable credential again, I will only get one because we just removed the other one. Same thing, you can use the delete all VCs API of the Snap to delete all the credentials if you want. Now you might be wondering where these credentials are stored. Well, they are stored within MetaMask itself, more specifically within the Identify Snap storage. Each Snap on MetaMask has its own storage that is secured through MetaMask's own security. And so everything that is being used by the Snap, like anytime you create a credential, like all of those, it just saves it to your account. That's why you're able to quickly retrieve it at a later time instead of having to generate it each and every time. You are also able to import a verifiable credential that you generated somewhere else over onto here, and I'm going to show that here. So first of all, there are two additional functionalities I wanted to show. So this particular Snap also supports configuring your Google account and then syncing your Google account. So what that means is, let's say you are on device 1, you have your like 50 credentials stored currently on device 1, and you want to back that up maybe, but you don't want to back up to some centralized server somewhere, but rather on your own personal Google Drive. So here we can basically let me do this. I will choose this. I can configure my Google account, and it says that currently I have not configured it, so let me configure to my Tuum.tech. Okay, it's configured. Now I can actually sync the Google VCs. So what that means is all the VCs that are currently on my Snap, but that are not on Google Drive, it will upload, it will export those to Google Drive. And all the VCs that are in Google Drive but not on our Snap, it will import. So it will do it'll do both of those jobs at the same time. So if I were to click on sync Google VCs, we're going to try this. There's one VC currently on our Snap. Let's see here. Import VCs from Google Drive. There's this is what we have. I already had that on my Google Drive, it looks like. This is the power of backing up. Now it's basically trying to export the VCs that I just created. Okay, let's see. Okay, So that's done. So now let me go ahead and try to retrieve the VCs. Okay. Let's see. All right, now we have the VCs here. Now let me go ahead and let's see. Let me go ahead and delete the VCs from my snap. Okay. Okay, I have deleted all the VCs from my snap. There are no VCs, so it looks like. Okay. Now let me go ahead and sync it. Okay. There's our VC. If we were to retrieve it, now we get back our VC that we created earlier, which is with the nickname hedera. All right, so those are all the features that the Identify Snap offers. Okay, as I mentioned earlier, this is just a demo site that we quickly created. Obviously, you can develop your own application and integrate with the Snap similarly to offer a lot of interesting use cases more than just displaying the VCs like we have here right now. For instance, maybe for you can use it for some kind of blockchain voting, reputation mechanism using the VC, login mechanism. There's lots of use cases here, but I hope that was helpful. See you in the next one.